Hello and welcome back to the second part of Chapter 2. We were talking about, let me scroll up here, structured related terminology. We had talked about data tables, validation tables, and then we were going to start on records and fields. So sometimes a record is referred to as a tuple. So hopefully you're taking good notes. So here is a particular table. At the top of the table we have our fields or our column names. So a record is part of that table. So I always think RR, like a train, or record and row. So a record is a row in a table. So it's a unique instance of that subject. So the subject of this particular table, we call it clients. So each row is a unique instance of a client. So this represents one client, this represents another client, and so on. So these fields or column names are facts about the subject of the table. And so each table then also has a primary key. And a primary key is a field or group of fields that when they combine that information together, it uniquely identifies the record. So in our case here, client ID, there's no repeating values. That is, there isn't another 9001 or a 9002 or so on. So those are unique values. They don't repeat. That could be used as our primary key. So knowing that primary key, that's going to be very important to understanding the relationships between tables. Now, if we go back here, we also have fields. Sometimes those fields, like I said, are also known as attributes. It's key to remember that the quality of the information that you get out of your database is directly proportional to the amount of time you spend on making sure the structural integrity and data integrity of the fields is as high as it can be. Because if you don't, then you're going to get sort of garbage information in, and it's not, when it comes out, it won't be correct. And then people won't be able to make decisions with it. So let's continue talking about fields. So these fields are part of that table. They represent the column, right? Each field represents a characteristic of the name of that table. So in our case here, this example would be clients. So it's the table and these fields where the data actually gets stored. There should only be one value in here. Right? Sometimes you will see people in a Excel spreadsheet where they might do first name and last name together and put that all in one cell. That's really bad because that limits your ability to search and get the correct data out. So anytime you have one piece of information, it should go into one cell or one field. So there should only be one value. Same thing with your address. You don't want to combine your city, state, and zip all in one field. You want to break that out. All right. Something your book doesn't talk about is that that when we look at these fields, once a table is normalized, then this primary key represents the key that tells me everything about this record. So it should also, that means that these non-key fields are fully dependent upon this key field. The key field here is client ID. So client first name, I should be able to get to that with client ID. And nothing else in this table. Client last name, I should be able to get to that with that client ID and nothing else in the table. Same thing for the rest of them. You see, and hopefully if I knew the client's first name, do I really know their last name? Because I could have more people with the same name of Stewart here for this first one. So when we talk about normalization, I just want to mention it now so you can get used to hearing it. Those other fields are all dependent upon that primary key. There shouldn't be any other key, other non-key field that would allow me to point back to some other non-key field in this row or record. When that happens, that's called a hidden transitivity, and that means you violated third normal form. We're not going to get into normal forms, but sometimes somebody might want to know if you know what third normal form is. And that means there are no hidden transitivities. Everything's dependent upon the primary key. The next thing we want to talk about is something called a query. It's also called a view. And what I mean by that is when you query, and especially when you use multiple tables that are joined and you retrieve data that's related and fields that are from one table and fields from another table, and then pull the related information out, that's going to generate another table that you view or you see. And so that's why it's called a view. Now, sometimes it can also be used for security reasons. So typically, a database administrator would generate a view for an analyst. And then that's the data that the analyst gets to start working on. Once the analyst has all their data that they need, they can then break it down however they want or query it further however they want. So you can also think of a query or a view as a virtual table composed of fields from one or more tables in the database. It doesn't have to be all the fields from the related tables. You can actually store that query in your database, and then as you add data to your database, those queries will get updated each time the query is opened. So that's what happens in Access. And so having a query, and it's with different types of data or different results that you're pulling from the tables, then that allows you to look at this data or information in multiple ways. And so you can ask all kinds of questions. I'm just bringing my notes over. And so these views that are important for multiple reasons, and the three of them here, it allows you to work from data from multiple tables at the same time. And I mentioned that already. It also enables you to prevent certain users from manipulating specific fields. That's what the security issues were from. So you don't want them to see, maybe you're in payroll, you don't want to see everybody's hourly pay or salary pay, and you don't put that in the view. You don't query that. And so then whoever's looking at that view, the results of that query, doesn't see that. And you can also use them to implement data integrity. So again, validation queries, making sure that the correct data is there. So continuing on, we're going to talk about some more structure-related terminology. And those are the keys. I talked about these already, but we're going to mention it again to make sure that it's really getting through. So the first key is the primary key. And this uniquely identifies the record in a table. It also identifies a given table in the database, that primary key field. And you should have a primary key field designated for every table in your database. This is the most important key in your database. Right? So it also enforces table level integrity, and that's what you're going to need in order to establish relationships with other tables. That is that primary key. So that primary key can be one field or it can be multiple fields. So we've seen in the previous chapter where you had an intermediate table called student class. that had two primary keys. The student ID and the class ID together represented the primary key for that table. And you would need to know both pieces of information in order to get to, say, GPA, or grade, I should say, grade for that particular class. The student ID and the course ID will give you the grade. But if you just knew one, you couldn't get to the exact grade without knowing the other piece of information. So you may want to go back and review that video. Alright, so you don't want to try and have a lot of composite keys because it can make it confusing. Sometimes people will just make up their own auto key in order to avoid a composite key. So notice how I said composite key. A composite key is a primary key made up of two or more fields. I've seen keys that up to 3 fields that were needed in order to uniquely identify that record. All right. So the other type of main key is the foreign key. And a foreign key is made up of values from the primary key field from another table. So think about that for a second. So it's the presence of the primary key values from another table, and that's going to be used to create the relationship. You would copy the primary key of table 1 into table 2 as the foreign key. Right? That would be the way the tables are linked. Now, in a primary key field, that column, all the values in it are unique. They can't be repeated. But in a foreign key field, the values can be repeated. When they're repeated and allowed to do so, that establishes a one-to-many relationship. Right? And notice here it says with limited redundant data. That's what we mean by redundant data, where the data is repeated. So your student ID can be found in multiple classes. So the relationship between student and classes or student and courses is a many-to-many relationship. Right? So it can be repeated both ways. And so when we do that link, that helps implement that relationship level integrity. Meaning that in the parent, I should say child table, the child table is the table that has the foreign key that you're linking to. That the primary key value that you've got in that table has to exist in the parent key or the parent table. So I've explained this before, and so it's like we've got registration, and we're going to put who's registering for the class, and we wouldn't, if somebody puts in a course or a student ID in a class registration table, and yet that student ID doesn't exist in the main student table, they shouldn't be allowed to register for a class. So that's the integrity level that having that primary key, foreign key relationship ensures does not get violated. So we've got an example here. Notice that we've got student ID is connected to student instruments, which is connected to instruments, and so on. So in this particular table, we've got a compound or composite key, student ID and instrument ID represent the primary key. Students here, student ID represents the primary key. All right. So the primary key, these fields can't repeat. Since this is a composite primary key, it can never have a combination of 60,003 and 1,000 again in this table, because that's the primary key that uniquely identifies this value here. That's not to say that I couldn't have student ID in a different instrument checked out again, or a different student ID and the same instrument ID here checked out on a different day. Okay, so it could repeat here. All right, so maybe this will explain it a little better. So notice here now we're looking at two tables, agents and entertainers. So the primary key here, these are their values. None of those values can repeat. But here's the foreign key field, same name. Doesn't necessarily have to be the same name, but it will have to be the same data type. Otherwise, you won't be able to do a link. And it is good practice to probably keep them the same name if you can. But notice here in this particular field that value can repeat. So again, there must be a one-to-many relationship here. And if a value is entered here, it's got to exist in the agents table. Otherwise, the integrity is violated, and we shouldn't allow that to happen, or the database won't allow that to happen. Okay? Hopefully that will make sense. If not, send me some questions, and I'll try to explain it a different way. The last term we need to discuss in this category is index. Index is a structure that a relational database management system provides to improve data processing. It doesn't have anything to do with the logical database structure. So if you're a database administrator, you need to figure out which fields need to be indexed. And what that means is need to be sorted in some order. And so it becomes a physical structure used to improve data processing. So the example here is, what if we wanted to know what agents were sorted with entertainers or associated with entertainers? Now, for something like this, we only have 3 records, but what if we had 3 million records? And the next time that agent ID 100 appeared in this particular table was at the 3 millionth record. Well, in order to pull all of those records, the database would have to say, okay, I'll pull whatever information I want out of the agents table for 100, match it up with this table, and look at every record for an agent ID of 100. All right? So if I have to sort through 3 million records every time to make sure I've gotten every entertainer for a particular agent ID, that's going to go really, really slow. But if I were to sort on agent ID, where all of the hundreds and 101s and so on were here, the computer could be checking for agent ID, and once it left an agent ID of 100, it would know it was finished. Okay? So that's the power of the index. It helps you not go through and have to look at every record for a match. You just know that here's where I need to start. I go through until that number changes. Once it's changed, I know I'm finished. All right, so when we come back, we will talk about relationship-related terminology.